Hey, happy Monday.
Happy Monday. How's it going, Joe?
Doing great. How was your weekend?
It was good.
Cool.
Yes.
You say that so sly, like it was
Uh,
good.
Nothing quite that exciting.
It's like,
Yeah,
right on.
yeah. Went out and got a couple drinks last night for the first time in a long time. It was
Nice.
kind of disturbing, but
Well, happens. Awesome. This week we want to talk about a question that actually landed in our inbox.
yeah,
So the question kind of involved somebody who's looking at both a data scientist and a data engineering role, with the
yeah,
notion that they want to be a full stack data professional. So I think we want to kind of unravel a couple things here, right? So what does full stack mean in the context of
yes.
data? And then, okay, say you wanted to pick a field or maybe both, data engineering or data science. Like, how do you even go about getting exposure, to what you need to know to be effective? So, like,
Yeah, and exactly right. And I think the big question here is like, how do you're not an expert in data engineering, you've been training in data science. How do you at least kind of figure out enough about the domain to decide if you're interested? Like, that's always a hard problem, right?
mhm,
Yeah,
yeah. So, I mean, let's start off with full stack. I mean, let's get that out of the way
yeah,
because it's a term that I think both of us hear quite a bit. Um, and it was a very, I think, prominent description of a skill set back in, the last decade to describe a software engineer, right? So I think the first time I remember seeing full stack was kind of when Mongo got popular, actually, and then you started seeing a lot of these, kind of, I don't know, pick a web framework, any framework, but it was like somebody who could, you know, do back end engineering and front end and get an app out, right? So,
but I think we tend to interpret this as something that happens at very small startups who don't have a lot of resources. And like you're fond of saying, it basically like shovels technical debt down the road. Like someone's going to have to deal with the problems that arise eventually by not having specialists. At the same time, it's a reality that you don't have specialists, you're not big enough to have them, and you just need to confront those problems.
mm-hmm. Yep, yeah, that's exactly it. And so it's a bit of, I think full stack's a bit of a misnomer, right? So in the sense that it's it is good at a certain point in the uh, data stack or team. I mean, probably especially when you're in MVP for the audience, minimum
Yeah,
viable product.
yeah,
Basically, trying to achieve product market fit, and
yeah,
you can't afford either monetarily or time wise building out a data team. Like your idea hasn't achieved any traction in the marketplace. Therefore, I would say that a full stack person does make sense at that phase. As you scale, as you point out, Matt, full stack ends up incurring a lot of high interest technical debt that you're
yeah,
going to have to pay off normally by a team of future specialists. Now, I guess a question for you is,
yeah.
when we talk about full stack, does that mean that you're good at certain technologies?
Probably, what I typically see is that people who are trying to do full stack, so they've created their own startup, they founded it, maybe they co-founded it with another person. They probably come into that with some experience. And so they're probably a specialist in a couple of things already. And so there's a tendency just to recycle what you already know. This can be good and bad. Like it's great that you've developed a web app and you know Postgres really well. That might not be the best solution for what you're trying to do right now.
For a data stack?
Yeah,
Yeah.
exactly.
Mm-hmm.
Yeah.
Yeah, what do you call it? The curse of familiarity,
Curse of familiarity.
right?
Exactly right. Yeah. Like things that look, I've seen this before. I'm just going to use it the same way. And it turns out that you really should be using it in a very different way, either because of the thing you're trying to do or because of the domain where you're working. So I think
Mm-hmm.
one example I use, the curse of familiarity, is that people get into the cloud. They're used to working with on-prem servers. And so they do things exactly the same way in the cloud.
Yeah, it's a big one.
Yeah.
So yeah, I don't think that being full stack means that you're like awesome at Kafka and
Right.
Spark and any other number of tools, which the ones I
Yeah.
mentioned, I mean, they're still used, but frankly, kind of old school. I would say full stack means that you understand, in the context of data, maybe the data engineering life cycle,
Yeah.
the data science life cycle, and how to operate across these life cycles. And knowing what tools to pick. Now, again, full stack, this is a
Yes.
bit of a different, I have been called a full stack, data person before because I've built data stacks and teams from nothing, right? And so, but I think
right.
back then, even compared to now, like it's the skill I would say you should be good at is obviously, like you said, knowing the data life cycles, but also understanding the tool landscape. It's changed a lot,
Yes.
right? So there's a lot of, whereas before you would have to be proficient at, setting up open source systems. A lot of that's been sort of obscured with the rise of managed services, best of breed third-party tools, et cetera, right? So.
Yeah. And if you're tempted to stand up your own, say, Postgres when you could use a managed version, think twice, because there are several problems with OpenStack. So first of all, there's the problem of not knowing what you don't know, right? Because you're not a specialist in all these different technologies. And another problem is that if you're doing full stack, then you're probably doing ops. And managing your own open source software, spinning up your own Kafka clusters is going to be a big operational burden that's going to pull you away from designing the app that you're trying to deploy.
Yep.
And so if at all possible, use managed services and use the simplest possible managed services so you can focus on what you're actually good at and what your unique idea is, not reinventing the wheel with something that someone else has done already.
Yep. Yeah, exactly. Because, when you're making MVP, like time is your enemy, right?
Right.
You only have so many days. You can measure those maybe in a small number of months, maybe a year. You don't have much longer than that to get something out and going. So to Matt's point, like don't spend your time with undifferentiated heavy lifting, or what I guess would commonly be called utility type problems, right?
Yeah.
Find a service that does these things well and get it going. Now, the question though, it comes back to, okay, so I don't know any of this stuff.
Yeah.
How do I learn it, right? So how do I learn to become a data scientist and a data engineer? I think to answer that question, my advice is don't actually find one or the other, but because these are two different disciplines with two different types of life cycles. For you to try and tackle becoming competent, and by competent I mean like employable in either of these fields, in tandem, I'd say you're not going to have a fun experience, and you're probably going to suck at it actually.
Yeah.
So just pick one. Can't tell you which answer though, right? Because that's up to you. Like, do you enjoy analytics and machine learning, and producing models and training models? If so, data science is probably more for you. If you like engineering mixed with data engineering is right for you.
Yeah. And I would say one of the things I have in my notes is that you want to do a lot of high-level reading. So what I mean by that is that, say you got a computer science degree, or even you came into software development through another path, and you've probably really learned to enjoy digging into a particular framework and doing programming exercises and solving problems at a very low level. But if you're anywhere near full stack, or if you're deciding between data science and machine learning, you need to be up here instead. You need to be thinking at a higher level of abstraction. And so you need to be reading about data practices. And rather than learning all the guts of Apache Spark, because that's what data engineers are supposed to do, you need to understand what Apache Spark is for and who uses it and how they use it. Because really at this point, you need to be in your decision framework, not in your low level, grinded out C code type frame of mind.
Yep. And I would say too, understand the big picture concepts, right? So, I mean, there's some great books out there. Designing Data Intensive Applications is one that we recommend to a lot of
fantastic book.
Data engineers, new or old. Our book will be awesome, but it's not going to be out for another year. So,
maybe we'll probably release a lot of blog posts along the way.
Yeah, we will. Yep. But there's a lot of great content, and for data science, to learn that, there's no shortage of materials. I would say learning data science is probably easier. But I'll caveat that with, it's not the same industry as it used to be even a couple years ago. It's very diluted. And especially if you're looking to get a job as a junior data scientist, it's just going to be a lot more competitive to do that. So keep that in mind. The field back a few years ago for, newbie data scientists, I'd say it was much easier to get hired just because of just that job market dynamics right now. I don't know if it's the same. So, and the number of companies looking for data scientists it's not as great as it was in the past. So you got to factor that in too.
And you have a lot of training programs out there. To be frank, that's one of the problems, right? You have people getting master's degrees in areas related to data science. You have a lot of computer science PhD programs that are focused on machine learning and data science. And on the machine learning, I mean, on the data engineering side, that's not as much the case so far. There are just fewer people being trained as data engineers, which definitely makes it an easier field to get into right now. And there's a great learning opportunity where you can jump in. And if you are ambitious and talented, you can learn very quickly on the job.
Mm-hmm. Yeah, and I'd say one aspect of this too is if you're a good data engineer, you implicitly understand the needs of data science, right? Because they're downstream customer, and so I would say it'd be really difficult for you to be a great data engineer, or even a passably good one, if you weren't aware of data science and the data science lifecycle and practices and so forth, right? So I think anyone who calls himself a data engineer should understand at least the basics of how machine learning works. You should understand the basics of analytics. That's pretty table stakes. Does that mean you become a data scientist? I don't know that's necessary for your job, although I could make a pretty strong argument that you will be a better data engineer as a result of diving into data science. Yeah. But that's only after you become a really good data engineer.
Right. And then potentially the door is open. I mean, frankly, if you become a data engineer and you want to shift to data science, you're going to have to do some work still, right? Even if you're very conversant in the field, actually becoming a contributing data scientist at your company is going to take some work. Nevertheless, with that solid data engineering foundation, like that's probably an easier way to get into data science than out of a boot camp or something, frankly, for the reasons you mentioned.
Plus, I mean, you got to realize too, domain expertise is like the most important thing you need as a data scientist, because it's applying math, statistics, various algorithmic approaches to, a domain, typically an employer's domain, right? So part of the question, though, I think, if I'm reading between the lines, is, well, I don't really have an employer right now, and I want to get a job, right? Exactly. So if that's your situation, then I would say it's less competitive to become a data engineer right now. And so my preference would actually be to go to data engineering and maybe make a segue into data science if that's even something you want to do. It's kind of like the question of trying to attack both at the same time, though, I think is just going to end up leaving you really frustrated in a very awkward place where you're not really good at anything, actually.
Right. And like I said, attack the decision at a high level. So learn a lot about the two domains, but don't try to become an expert in TensorFlow and an expert in Spark and an expert in SciPy or whatever framework, every possible framework. That just doesn't work. You need to make some decisions and then start specializing afterward.
Yep. I mean, talking about technology for a bit, though, right? So, say you want to get exposed to various technologies. What do you recommend?
Yeah, so one of the great things about cloud plus numerous software as a service platforms is that you can just jump in and start experimenting while spending very little money. Obviously, okay, so you don't have a job yet, you don't have a lot of money to spend on a cloud account, say, but you can do things like jump into cloud data warehousing and experimenting almost immediately. Turn on Amazon Redshift, turn on Google BigQuery, turn on Snowflake, and just start querying data and see how you like that experience. Turns out that is a very good crossover experience because I think increasingly both data engineers and data scientists need to have really good SQL skills and cloud data warehouse skills for that matter.
Yeah, there's also, you'll hear paradigms like streaming. I mean, I think we both suggest starting with less complicated stuff and then moving towards complicated. So maybe an example of this is, if you're in AWS, for example, spin up Kinesis, maybe even spin up SQS, learn how messaging works, and then, spin up RabbitMQ, open source version, spin up managed Kafka, for example, then spin up the same thing using the open source package, and just try to understand, okay, so like, what's the similarities? What's the difference of these two approaches? Why would I choose one or the other? I think there's something to be said for trying out the open source versions because you really do understand how things work, kind of at a more fundamental level. And whereas managed services do obscure quite a bit of complexity, I think going through the exercise of deploying open source will make you appreciate the amount of complexity that is removed if you move to a managed service, which if you're starting out, again, as a full stack data person, we always recommend going with managed services first, unless there's some special sauce, which is a strategic advantage. There's no reason for you to do that in this day and age.
Yeah, you just don't have enough people to manage custom, open source deployments.
Mm-hmm.
I mean, you do not have the scale of ops teams. Managing that kind of technology is a challenge for very large op teams with separate developer teams.
And with a lot of experience.
With a lot of experience.
These tools, right?
That's right.
I mean, we know a lot of Hadoop teams out there, and these guys are, and gals are very expert in what they do, very highly paid, and very, it took them a long time to get there with these skills.
Yeah.
So, but again, if you're going to be full stack, for example, right, that doesn't apply to you by definition,
right?
Because these are very deep specialists. You're by definition a full stack, a very wide generalist. It's orthogonal.
Yeah.
So.
Yeah. But to your point, I mean, playing around with these technologies still makes sense to gain some domain knowledge. Just don't be tempted. Okay, I spun up Kafka on my laptop and tried it out. It was awesome. Now I'm going to deploy it into production, and it's going to become a key piece of my SaaS that I'm building, my product. Like, don't be tempted to do that too quickly.
Yeah. Yeah, exactly. And you'll see some other technology, like orchestration's one you'll hear, like that's popular. You want to talk about Airflow for a bit and maybe some alternatives?
So, and one thing I'll say is that typically, so first of all, Airflow or some kind of orchestration is pretty central to most data flows these days. And it tends to reach across both the data engineering side and the data science side, in the sense that data scientists will need to deploy model training into an orchestration system so that it can happen downstream of data processing that feeds the model training. But typically, these systems are actually managed more on the data engineering side, and then data scientists will interact with them and perhaps write code and deploy it into these systems without managing the system itself. So right now, I think in the kind of open source domain, the most popular solution is Apache Airflow. There are a number of different fully managed options, which you can try out quickly. So you have things like Google Cloud Composer, Astronomer.io. I think Amazon's is like Amazon Managed Workflows you can experiment with. Try out something like that and just experiment with orchestration and how to manage these complex flows, because that's a good skill to have, whether you're in data science and data engineering. And it will give you a flavor of what the data engineer's job is all about.
Now, let me ask you this. So do you think that, there's some competitors to Airflow right now. You got Prefect, you got Dagster. Do you think somebody should learn Airflow or one of these newer technologies?
I think you should get exposed to the different technologies. And then you'll have to make some decisions. Is your employer going to go with Prefect, for example? One nice thing about learning the dominant technology is that you can shop that around as you're searching for a job. There are a lot of places that either are already using Airflow or are looking for people to deploy it. And so if you've built up a pretty good body of knowledge around it, that's going to help you to find a job.
Yeah. And I would even say, too, with newer technology, say, a company hiring a data engineer or data scientist is looking for skills maybe in the newer technology. Knowing the old technology actually sort of implies you're able to pick up the newer technologies. I mean, if you look at Prefect, for example, it was made as a response to some of the limitations of Airflow, right? So knowing Airflow gives you context to pick up the other tools, and maybe vice versa, but I would say start with the more popular tools and then work your way into the newer, maybe I wouldn't want to use the word obscure, but maybe less popular tools for now. Yeah. And so, and I think another piece we want to hit on is like learn technologies and paradigms that work across professions, right?
Yes.
So
get really good at SQL. SQL remains an underappreciated technology, but I think we share the opinion that SQL has actually grown in importance because of cloud data warehousing. You have these very powerful data processing engines that run on SQL that are highly tuned and optimized, and there's not a lot of management to do. So I'm talking about, again, Redshift, BigQuery, Snowflake. You can do a lot of data engineering in those systems. You can also do a lot of data science and featureization in those systems if you're good at SQL.
Python's another one?
Python's another one. Yeah, right. Python shows up all over the place. So for example, Airflow is written in Python. So are a lot of core data science frameworks. Python is also, I think, the primary API for TensorFlow, for PyTorch. Like you're really going to boost your career by being really, really good at Python.
Yeah, it's everywhere right now. I mean,
it is.
I think some people would argue, well, you should also learn R. And I would make a counter argument that if you're looking to sort of cross between data engineering and data science, don't learn R. It would be good to learn later.
Yeah.
but Python is a language that's used universally across either data
Right.
engineering or data science. You can't say the same thing for R.
That's right. Yeah. And I think, I mean, I've talked to some of my friends who are R specialists, and it sounds like the R ecosystem has gotten some major boosts in the past maybe 2 years
Hmm.
compared to where it was 5 years ago. But still, I mean, Python remains dominant. So think of Python as your foundation language. Like everyone, it's kind of table stakes. It's just a standard skill that any data scientist or data engineer should have. And then, yeah, R is an add-on on top of that,
It is,
potentially.
I could make a good argument too that your second language may not, or your third language actually, if you count SQL,
Yeah, yeah,
is Python SQL, and then maybe something else because depending on the direction you go,
yeah,
um, if you're leaning more towards data engineering, I don't think you need to know R. I would actually be looking at either a JVM based language, Java or Scala, because that's what a lot of the open source
Yep.
big Apache projects are built in,
Yeah.
and also look at languages like Rust and
Yep.
Go, which are
Yeah.
increasingly, I would say, getting more popular even than the JVM languages. I know it's going to take a bit for them to supplant the JVM languages, but there's a reason these are gaining in popularity because they're fast and performant and simple to use, unlike
Yeah.
languages that start with a J and end with an A.
Right.
So,
Yeah.
um,
And
what's that?
I'll just say it for the JVM based languages, it really depends on what you want to be doing. But yes, in particular for Spark, Scala is going to be important. If you're interested in like Apache Beam, then Java is kind of the native language of Apache Beam.
Mm-hmm.
Yeah.
Yeah. Um, I guess we talk about the cloud.
Yeah.
Any advice there?
Yeah, so this, if you're interested in certifications, and I think you should be, jump back to our Monday morning data chat on certifications. We'll drop a link into the video notes for this show.
Mm-hmm.
And in particular, consider getting a foundational cloud certification, regardless of what you're interested in. Because if you're a data scientist on a small team, then you'll probably be tasked to do some operational things in the cloud. Data engineers now almost always have to work in the cloud, unless, say, you're working for Facebook, which basically has its own internal cloud. Take a look at Google Cloud Platform, at AWS, and Azure, and decide from there what you're most interested in, what you'd like to work in, and then look at their associate level certs. So these clouds have associate level and pro level certs. Start with the associate. So I think in Google, it's like the associate cloud engineer. On Amazon, it's associate solutions architect. It builds a really good foundation, and it also teaches you a lot about operating in the cloud, and it will help you to learn what kinds of things you like. And in fact, if you really, really enjoy those exams, I mean, I don't know if anyone really enjoys exams, but if you enjoy the things you learn and things you do, that might be an indication that data engineering is for you.
Mm-hmm. Yeah, because I mean, regardless of where you are in the full stack spectrum, whether you're more data engineering or data science, you're still going to be expected to deploy stuff in the cloud. And so, yeah, I mean, that's absolutely right. And again, I mean, some people, we talk about this ad nauseum, but yeah, we're of the opinion, go with certs. If people tell you wrong, they can come talk to us. But these clouds have a particular way of doing stuff, right? And it's not like you're just going to figure this out magically by using them. I can't count how many errors we see, either from like benign errors all the way to like mission critical errors that can like sink the viability of even your MVP. So like I think if I were to look back on my career, one of the things I wish I would have done was just take a deep dive into these clouds early and understand how they want to be used. There's a certain way that you use AWS, for example. There this is, and you'll learn about it when you study for it. And I've been in AWS since like 2009 or 2010, so I've been using it for quite a while. And even and still, I learn something new all the time. So yeah, certs are important. And to sort of recap, the initial question, like how do I become a data scientist and a data engineer? I think our advice is pick a direction. So.
Yeah, and again, acquire the high-level knowledge, get exposed to a lot of different technologies, and pick a direction. And then I think generally we've seen that you can definitely cross over once you get good at being a data scientist or a data engineer. There are opportunities to switch over to the other profession once you're a part of the club. Once you're part of the data club and you've shown that you're good at data, you can start to pick a different direction. Even though it might be a slight speed bump in your career, it might be the right move if you know that you're going to be a lot more happy for the next 20 years switching from data engineering to data science or vice versa.
Mm-hmm. Yeah, or whatever those things are called in the future,
Yeah,
right?
yeah, exactly.
So, yeah, because I mean, we're talking about these two fields, I think, at a very interesting time for these two fields. The role of a data engineer, I think, is morphing. It's moving away from, I would say, being so heavily focused on low-level systems, and more being able to understand how to solve problems across the data engineering lifecycle. The same thing's happening in data science, whereas the conversation several years ago was, what's the best way to train a model? That's very much a solved problem for most use cases. And of course, this, there's always going to be AI research coming up with new stuff for variety of problems that most companies have. It's solved. In fact, I can make a strong argument that AutoML solves a number of very common pedestrian type of problems. Image classification, for example, NLP. This kind of stuff is very much in a good spot. And unless you have the need to, build on top of these AutoML APIs, for example, just don't waste your time. Especially if you're a full stack person, your time is best spent like time to market, product market fit, that kind of stuff. But again, I think what Matt and I are trying to say is too full stack. It's a bit of a fantasy, right?
Right.
So maybe someday will get there, but out of the gate, I don't think so.
Yeah. Well, and basically the best way to be full stack, because sometimes you have to be, again, you worked at startups. I think you had to be full stack frequently because there was just no one else to do the job. And back then it was very hard. It's gotten way, way easier because of managed services. And so take advantage of all the tools that we have in 2021 that didn't exist in like 2010. And that will make you much better at your job, because instead of spending your time babysitting a Kafka cluster that goes down all the time, you can think about what's actually going to help your startup to make money and be successful.
Well, and I started out, I mean, it's not like I started out as a full stack data person, right? I mean, I had at the time, at least 10 years of experience already doing whatever data science is, right? So I kind of knew how to solve that type of problem. And the reason I started doing data engineering was because it needed to be done. How are you gonna like create new processes that makes data science better? How are you going to engineer production grade systems? Data science alone isn't going to solve that. But back then, data engineering wasn't even called data engineering, which is called software engineering, actually. Or
data science, right? I mean, reality is data scientists end up doing a lot of data engineering type tasks, and you can approach it. You can do a good job at that, or you can do a really poor job. You can treat it as important, or you can treat it as just a nuisance that you have to deal with.
What was that old Drew Conway Venn diagram of what a data scientist is? That was like 2010, I think.
Yeah.
So it was like domain expertise, like what math, hacking skills, and then math skills, or some weird thing. And that was an archetype, I think, back then. Now it's just everything's changed, and I think that's the whole point to what Matt and I are saying. It's like just there's more complexity now.
Yeah. I mean, we shouldn't be surprised that. How long has data science been around? The notion has been around for a long time. The term maybe
the term I think came out in the 70s, actually.
Yeah.
But the modern version that DJ Patil came out with, I think that was like late 2000s or something like that. But they intentionally left the definition open-ended because I don't think they ever committed to saying this is what data science is.
Yeah.
So I only learned that in some random interview I read where they kind of asked, what were you planning on? Is having a definition that no, we kind of left it open-ended. So for better or for worse, I guess. But
well, we shouldn't be surprised though that people have specialized, right? The companies have specialized. What's really happened, I think, is that the data science profession is split into multiple parts, and in some sense data engineering is one of those parts, and then data science has become a bit more specialized than it was before.
And that's the name of the game. I would say there's enough complexity across the data lifecycle right now, whether you're talking about a data engineering lifecycle or data science lifecycle. We should probably do a podcast on this at some point. But there's enough complexity across any stage of this where that is almost a discipline where you could go pretty deep, right? Storage, for example. That's an area where I would say you could make a whole career just out of being like a storage expert. You can make a career out of being, an ingestion expert and so forth. So, it all depends on where you work.
Yeah, go work for one of the clouds. I mean, Amazon is constantly evolving S3, their main storage product, and Google is constantly evolving their storage products as well. I mean, there are definitely opportunities there. But if you're at a startup, you're probably not going to become a storage expert. Just use what someone else has
There you
already
go.
done.
Yep, exactly. Well, cool. Anything else we want to cover on this?
I think that's about it for
About
this
it?
week.
Okay. Right on. All right. Well, hopefully this was helpful. Again, pretty large topic to cover. I understand. So, but we do what we can. So
yeah, hopefully some useful guidance if you're just getting started in your career, or even if you're looking to make a change.
yeah, I think again the basis is like it's not an and question. It's an or answer, right? So yeah, awesome. Well, until next time, talk to you, Matt. So
all right, sounds good.
See ya.
Talk to you soon.
Bye.
Bye.